Good evening, friends. The exciting times here, and now you know the news. Or perhaps you don't. Because tonight, we're cracking open a letter sent to the exciting times. A letter unlike any other. A letter that can push the boundaries of science and engineering. A letter with instructions on how to build a flying saucer. Yes, you heard that right, a flying saucer. Not a UFO from the night skies, but a machine grounded in physics and engineering principles. And if you're wondering whether this is plausible, let's take a closer look at what was detailed in that remarkable correspondence. First, the design itself. The letter described a classic flying saucer straight out of the 1940s, a sleek, silvery disc with a domed top and tapered edges. The diameter? 20 feet across, just wide enough to house the intricate machinery required to generate lift. The height? 6 feet from the base of the peak to the dome. A compact aerodynamic marvel. The heart of this machine lies in the two counter-rotating magnetic fields. Imagine this. Massive coils of copper wire wound tightly around a ferrite core, spinning within a superconducting outer rotor. These components rotate in opposite directions, creating an electromagnetic field interaction that, through the principles of the Hall effect, could generate lift. Now, the Hall effect. This phenomenon occurs when a magnetic field is applied perpendicular to the flow of electric current within a conductor, producing a measurable voltage difference across the conductor. In this device, the counter-rotating fields create localized electromagnetic forces interacting with the environment in a way that generates an upward thrust. Such a mechanism relies on precise control of field strength and frequency to achieve stability and lift. To monitor and optimize this process, the letter proposed lift sensors. These sensors would use inductive displacement and Hall effect mechanisms to measure variations in magnetic flux density and the resultant forces. For example, an array of Hall effect sensors placed strategically around the saucer's frame could provide real-time feedback on field symmetry and lift efficiency. Inductive displacement sensors would measure positional changes in response to electromagnetic forces, ensuring precise control during operation. The power source? A lithium-ion battery pack with a capacity of 100 kilowatt-hours. This would supply the energy needed to drive the electromagnetic field generators. The battery's output would be converted from direct current to alternating current by a sophisticated inverter designed to handle the high frequencies required for precise field modulation. A liquid cooling system, featuring pumps and aluminum radiators, would maintain operational temperatures, ensuring the superconducting coils and other components function without overheating. The materials list was meticulously detailed. Aluminum, alloy, sheets. For the outer shell provided a lightweight yet sturdy structure. Carbon fiber reinforced polymer beams added internal rigidity. High conductivity copper wire formed coils, and superconducting tape carried high currents with minimal energy loss. Every element of this design was chosen for its performance and feasibility. The saucer's landing system comprised 3 retractable legs engineered to fold neatly into the body during flight and extend the stable landings. This blend of engineering simplicity and functionality underscored the thoughtful design. Safety was emphasized throughout the letter. The writer advised installing relays and circuit breakers to prevent overload and shielding components to minimize electromagnetic interference. Testing was to be conducted in isolated areas to ensure safe operation. Now let's talk about another mystery that's been buzzing around the aviation world. Airline pilots near Los Angeles have been reporting sightings of what they dubbed the Rocket Man, an individual seen flying around high altitudes with what appears to be a homemade jetpack. While authorities continue to investigate, one theory suggests this could be the work of a home inventor, someone tinkering in their garage and pushing the limits of personal flight technology. If a jetpack can be built in such a way, could the flying saucer from this letter also be within the reach of a determined innovator? What makes the story all the more intriguing is the anonymity of the sender. No name, no address, no signature, only a set of schematics and technical descriptions that align with known physics and engineering principles. The tone was confident, the details precise, as if authored by someone deeply familiar with advanced electromagnetic systems. Could this be another backyard inventor, quietly advancing the frontier of human ingenuity? So, is this the blueprint for the future of transportation? A glimpse into a bold new era of flight? Or perhaps just the next chapter in humans' endless fascination with defying gravity? With the Rocket Man soaring over California skies and letters like this landing in our inboxes, it's clear that the spirit of innovation is alive and well. Elon Musk, if you're listening, you know where to find us. Our inbox is always open for a conversation about the future of flight. Dear listeners, those are the facts. The rest is up to you.